All right, we're going to look at how to do heating curve calculations today. I'm going to do the first example on the front with you, and then you're going to do the example on the back. So the first thing we need to do is look at the question. It says the graph shown below is a heating curve for water. Determine how many kilojoules of heat are needed to melt 50 grams of ice at negative 20 degrees Celsius to steam at 100 degrees Celsius. So when we look at our heating curve, we're going to start way down here with our ice at negative 20 degrees Celsius, and then we're going to take it up to point B, which is the melting point. We're going to melt all of the ice, then we're going to take the water up to the boiling point. We're going to boil all of the water and then take the steam up to 120 degrees Celsius. So we're going to have 1, 2, 3, 4, 5 separate calculations that we have to do for each little section of our heating curve. All right. Now, you're going to need these 2 pages in the textbook to look at the charts for the constants we're going to be using for our calculations. Okay, so to begin, we're going to look at this first little section, AB. Now, in AB, the temperature is increasing by 20 degrees Celsius. So when the temperature increases, we use the formula delta H equals Cm delta T. So we're trying to find the heat involved in that temperature change. So we want the specific heat of ice, the mass of ice, and the change in temperature of the ice. Now, on page 296, we can look up the specific heat of ice, which is 2.1 joules per gram degree Celsius. And then the mass was given in the problem, 50.0 grams. And our change in temperature is final minus initial. 0 minus negative 120, or negative 20, sorry, is a change of 20.0 degrees Celsius. So when we multiply those 3 together, our units cancel, and we end up with 2,100 joules. Okay, so now we're at point B. So to get from B to C, the temperature stays constant, so we can't use our change in temperature. We have to use the delta H of fusion because we are melting all of that ice. And the delta H of fusion on page 308 in your book for water is 6.01 kilojoules per mole. Now we don't have a mole, we have 50 grams. So we're going to have to take our 50.0 grams over 1, convert it to moles, and to do that we use the molar mass of water. And then we use our heat of fusion as our conversion factor. And that gives us 16.7 kilojoules. Okay, so we've heated up the ice, we've melted all of the ice, now we have water right here at 0 degrees Celsius, and we need to heat the water up to the boiling point. So we're changing the temperature. So from C to D, again, we're going to do delta H equals Cm delta T. This time we want the specific heat of water instead of ice because we're in the liquid phase. So back to page 296, the specific heat of water is 4.18 joules per gram degree Celsius. Mass is the same, 50.0 grams. And our change in temperature this time is from 0 to 100, so 100 degrees Celsius. And when we do that calculation, that gives us 20,900 joules. Okay, so now we brought all of our water up to 100 degrees Celsius. Now we want to turn it into steam. So again, our temperature is being held constant. So for our next section, we're going to have to use the heat of vaporization. And on page 308, the heat of vaporization for water is 40.7 kilojoules per mole. So we're going to take our 50.0 grams of water, convert it to moles, same as we did before. This time we use the heat of vaporization as our conversion factor from moles to kilojoules, and that gives us 113 kilojoules. Okay, so now our last step is to take our steam and heat up to 120 degrees Celsius. So for section EF. We're going to change the temperature. So our specific heat of steam, go back to page 296, 1.7 joules per gram degree Celsius, times our mass, 50.0, times our change in temperature. Now from here, we are going from 100 degrees Celsius up to 120 degrees Celsius. So our delta T is 20 degrees Celsius. We multiply those, our units cancel, and we get 1700 joules. Okay, so how do we find the total amount of heat that it takes to get from point A all the way up to point F? Well, we have to add up all of our sections. Our problem is some of them are in joules and some of them are in kilojoules, so we have to put them all in the same unit. So we're going to change all of our joules to kilojoules. So we have 2.10 kilojoules, 20.9 kilojoules, and 1.70 kilojoules. Now when we add them all together, the total delta H comes out to 154 kilojoules. So to add all of the changing temperature and changing state, it would take 154 kilojoules to get from negative 20 degrees Celsius up to 120 degrees Celsius if we started with 50 grams of ice. So now you're going to do the same thing on the back. Here's the difference. You're going to be using ethanol. It gives you, in your book on page 308, it gives you the melting and boiling points, and you're given all of the information you need in the problem. So you need to follow the same steps that I did on the front, but with ethanol and all of the numbers and the constants that go with ethanol. So make sure you pay attention to page 308 and page 296 and work on the calculations on the back.